Okay, so we've stated the properties of logarithms. That is, that log base b of a product can be rewritten as the sum of the two logs. The log of a quotient or division problem can be written as the subtraction or difference of the two logs. And finally, the log of something to a power can be written as that power times the log of the expression. And so logarithms have these unique properties. And using these properties, we can rearrange problems involving logarithms. There's two things that we can do with logarithms. We can take a logarithm involving several things and break it apart into separate logs. We refer to that as expanding logs, and that's what we're going to discuss in this video. And the other thing we can do with logarithms is take a string of logs being added or subtracted and combine them into a single log, and we'll look at that in the next video. So what we want to talk about here is expanding logarithms. And so let's see an example of what I mean here. Here we have a log, this happens without the subscript being log base 10, of x squared times y cubed. So our property up there says that the log of a multiplication problem can be broken down into the sums of the two logarithms. So we can take that log of x squared y cubed and break it out as log x squared plus log y cubed. That's what that multiplication property allows us to do. And then very often, once we've done that step, either with the addition or subtraction properties, we'll be able to use the power property. So we see that we have a log x squared. Property number 3 there says that if you have the log of something to a power, the power can be pulled out. The same thing happens with log of y cubed. And so we get as our answer 2 log x plus 3 log y. Okay, let's continue with a second example here of this idea of logarithms. This is a little more complicated. We have the log of a fraction, so we have x cubed and square root of y in the fraction, in the numerator of the fraction, and we have a z squared in the denominator. Well, using property number 2 there, if we're dividing by something, that's going to end up being subtracted, just like that log of n, log base b of n is subtracted there. Anything in the denominator is going to be subtracted. Anything that's in the numerator will be positive. And so when we come to this problem here now, we break it up as log of x cubed. And then the square root of y I've taken the time to rewrite as an exponent, as y to the 1/2. It was in the numerator, so it's plus, and then minus natural log of z squared. Okay, and then just like we did in the last problem, we can pull the exponents out. And we get 3 natural log x plus 1/2 natural log y minus 2 natural log z. Okay, consider the next example. Once again, we have a log base 10. We have log of x plus 1 over log of x squared y cubed. So because the x squared y cubed is in the denominator, when we expand that out, those are both going to be subtracted. Be careful, the log of x plus 1, you can't distribute a log over addition, so that's just going to stay as log of x plus 1. And then minus log of x squared minus log of x cubed. And then we continue just like we did before. We can pull out the exponents on that log of x squared and that log of y cubed. Again, they're both subtracted because they were both in the denominator. And so log of x plus 1 we can't do anything about. That's just going to stay as log of x plus 1. And then minus now 2 log of x and minus 3 log of y. And we have one more example that we want to look at. This one's a little more complicated. It begins as a subtraction problem, and the first thing you have to kind of keep in mind is I cannot expand the log of x cubed over the x cubed minus 4x. But what I can do with that x cubed minus 4x is I can factor out a common factor of an x, and then I notice to myself that I'm left with x squared minus 4, which I can factor as well. So I have log base 2 of x times x plus 2 times x minus 2. Those are all being multiplied So now I can apply my multiplication property, which says I can break those into sums. And so we get our final answer, log base 2 of x plus log base 2 of x plus 2 plus log base 2 of x minus 2. Okay, in the upcoming video we're going to look at basically taking what we've just done and reversing it. Now, these two ideas of expanding and what we'll look at next, compressing logs, have their uses in different contexts. The context where you're mostly going to find expanding logs like this to be beneficial is in calculus, when you're doing things called derivatives. The second thing we're going to look at, compressing logs, is actually going to very quickly have a use in algebra when we're solving equations. Okay, so till next time.